Hey everybody, it's Mr. Carr again. Today we're going to be looking at 8.2 Day 2, calculating arc length and sector area. Now, you would have done these back in geometry, most likely focused just on degree measures. But today we're going to be looking at arc length and sector areas in terms of radians. Okay, so we have two formulas very specifically for this. Arc length can be r times theta, and then sector area is 1/2 times r squared times theta. And again, this is only if it's in radians. Okay. So if you need to, you can, if you're given degrees and you want to use these formulas, then you could always convert. Okay. Convert by using, oops, pi over 180 degrees. Okay. So always just multiply by that, and then you'll be able to change it over to radians. So find the arc length and the area of the sector with a given central angle. So we do have radians here is 4 pi over 5. And we have our radius of 12. Okay, which, oh, sorry, two different problems here. My bad. Okay, so first one we're looking at is 100 degrees. So let's turn that over into radians. So I'm going to take 100 times pi over 180. So the fraction 100 over 180, which is going to reduce down to 5 pi over 9. So that's going to be my radians. So for my arc length, so we'll call that L for arc length. That is going to be radius times theta. So that's going to be, in this case, 7 times 5 pi over 9. Okay. So that's going to come out to 35 pi over 9, which when I plug in my calculator comes out to about 12.22 centimeters here. So for area, that's going to be 1/2 times, we'll write the formula down, r squared times theta. So in this case, that's going to be 1/2 times 7 squared times 5 pi over 9. And that's going to come out to, I'm just going to put my calculator away. So that comes out to about 42.76 square centimeters. So remember, this is sector area. So it's square centimeters versus centimeters. For the next one, we're already in radians. So I just need to put those into their formulas. So arc length is going to be 12 times 4 pi over 5. So I just put that in my calculator and I get 30.16 feet. Okay. I don't like the way I wrote that, so let's fix that a little bit. 30.16 feet. All right, area is 1/2 the radius, so 12 squared times my theta here. Okay, so A is going to be approximately equal to 180.96 square feet when I plug that in my calculator. Okay, softball field forms a sector with the dimension shown by the length of the outfield fence and the area of the field. Okay, so it's tough to see here, but this is 90 degrees. So one thing that make it easier is if I first convert 90 degrees into radians, which is actually not too bad because that is just pi over 2, because it looks like this. Okay, so it's pi over 2 or 90 degrees there. So that means for my arc length, I'm going to do pi, or sorry, r times theta. So that r in this case is going to be 180 times my theta, which is pi over 2. Okay, so I put that in my calculator and I get 282, oops, 282.7 feet. So that is how far it is to run from here to here on the outfield fence. And then for area, that's going to be 1/2 of my radius squared times my pi over 2 there. So I put that in my calculator and I get 25,446.9 square feet on that one. Okay. And that's it for today. So we're just doing arc length. That is, again, the distance traveled on this circular part here. And we're doing sector area. That's the amount of space that takes up a portion of the circle. Okay. So we have two different formulas, and both formulas are based on being in radians. Okay. So that is it for today, and take care, everyone.